morning student. Today we will see next unit process, diazotization. Okay, diazotization. Do you know what is mean by diazotization? Okay, diazotization is a reaction of aromatic amines, mostly aromatic amines. That aromatic amine, it should be mostly primary aromatic amine, or it may be secondary aromatic amine, or it may be tertiary aromatic amine. Okay, such type of amines undergoes this diazotization reaction. Who discovered this diazotization reaction? This diazotization reaction was discovered by Peter Grice in 1858. So what is this diazotization reaction? Let us see. Okay, what is this diazotization reaction? Let us see. Okay, see, in diazotization reaction, aromatic primary amine we will take, isn't it? It is reacted with a solution of sodium nitrite and hydrochloric acid, or it may be sulfuric acid. So we will get aryl diazonium salt. What we will get? Aryl diazonium salt. See, for this reaction, that is for diazotization reaction, we will require very lower temperature, and that temperature is around, we can say, 273 degree Kelvin or 0 degree Celsius. 273 degree Kelvin or 0 degree Celsius. So such type of, that means such type of reaction condition is required, 273 degree Celsius or 273 degree Kelvin or 0 degree Celsius. Okay, now let us see some example. We will take an example of aniline, aromatic primary amine. So it is reacted with sodium nitrite and hydrochloric acid. See, initially there is a reaction between the sodium nitrite and 1 mole of hydrochloric acid. Okay, so this sodium nitrite and 1 mole of hydrochloric acid will react with this hydrochloric acid. So there will be a formation of nitrous acid. There is formation of what? Nitrous acid. Isn't it? HNO2, nitrous acid. So I will write it as OH N double bond O. This is what? A nitrous acid. OH N double bond O. Okay, so aniline will react with this reaction mixture of sodium nitrite and 2 moles of hydrochloric acid at 0 degree Celsius or 273 degree Kelvin. So there will be a formation of a benzene diazonium chloride. There will be a formation of benzene diazonium chloride along with a byproduct NaCl and 2 moles of water molecule. So this is what? A diazotization reaction. Okay, so in diazotization reaction, sodium nitrite is reacted with what? Hydrochloric acid. There will be a formation of this nitrous acid. So this nitrous acid is a actual reacting species. This nitrous acid is a actual reacting species in this reaction. So this nitrous acid, okay, this is what the structure of nitrous acid. It will react with this aniline, isn't it? and that aniline is on reaction with what? Nitrous acid at 0 degree Celsius or 273 degree Kelvin. It will give what? Benzene diazonium chloride. It will give benzene diazonium chloride. So this is what? A diazotization reaction. Now there are some difficulties. Okay, there are some difficulties are observed in diazotization reaction. Okay, when we are carrying out a diazotization reaction in laboratory, some difficulties are occurred. So these difficulty, which are these difficulty and why those are arise, that we have to see. Okay, so the difficulty are, first difficulty arise is due to what? Low reactivity of aromatic amine, low reactivity of aromatic amine due to electron withdrawing group, due to presence of electron withdrawing group. Have you understood this? Low reactivity of aromatic amine due to presence of electron withdrawing group. For example, para-nitroaniline. Okay, para-nitroaniline or 2,4-dinitroaniline. So if such type of electron withdrawing group is present on this aromatic ring, okay, on a amine, then this group, electron withdrawing group, will lower the electron density of this NH2 functionality. Okay, that means this lone pair will not available that much, isn't it, for this diazotization reaction. Hence such type of difficulty is observed. Okay, so these type of amines, they are getting slowly reacted in diazotization reaction. Second difficulty is what? Low solubility of some aromatic amines, low solubility of some aromatic amines in aqueous acidic medium, isn't it? Low solubility of some aromatic amines in aqueous acidic medium. That means some aromatic amines are not easily soluble in what? 1H2 HCl. Okay, if you have carried out this reaction in laboratory, okay, in FYBSc, in SYBSc, at that time you have taken that amine and you have dissolved in what? In 1H2 HCl, and then you have cooled that solution and you have added cold solution of sodium nitrite in it. Okay, so we want aqueous acid. 1H2 HCl means what? 50% concentrated HCl and 50% water. Okay, that will give what? 1H2 HCl. That is what? Aqueous acidic medium. So low solubility of some aromatic amines in aqueous acidic medium. So which are these aromatic amines? So these aromatic amines are of the type okay. So when this amine, okay, this is what? Alpha naphthyl amine. Alpha naphthyl amine, and this alpha naphthyl amine is having sulfonic acid group on its structure, in its structure. Then this will be what? Naphthionic acid. Okay, so there will be a formation of zwitter ion. There is formation of what? Zwitter ion of this type of compound. So there will be a formation of NH3 plus and SO3 minus. isn't it? So because of this jitter ion, or you can say because of presence of acidic group and also basic group in the same structure, this type of amine will be lower soluble in aqueous acidic medium, isn't it? Hence we will get some problem in diazotization reaction of such type of amine. Now next point is what? Some aromatic amines contain easily replaceable or oxidizable groups in its structure, isn't it? Some aromatic amine contains easily replaceable or oxidizable group in its structure. When such type of easily replaceable or oxidizable group are present on aromatic ring of basic amine, then again there is problem of what? Diazotization reaction. So which are these type of amine? For example, if we take aniline, okay, and if it is contain hydroxyl group on its structure, that means aniline ring is having hydroxyl group, then this hydroxyl group can undergo oxidation, then that hydroxyl group can undergo oxidation during these reaction conditions. Hence we will get lower yield, we will get some side chain reaction, hence we cannot carry out diazotization reaction on such type of molecule also, isn't it? We cannot carry out diazotization reaction on such type of molecule, that is aminophenols, isn't it? So these are what? Some trouble or some difficulties observed in laboratory during what? Diazotization reaction. Okay, now we have seen what is this diazotization. Now can you tell me, can we take any other nitrosation reagent, that is diazotization reagent? Is there any other diazotization reagent that we can use for diazotization reaction? Which are that reagent? That means instead of sodium nitrite hydrochloric acid or instead of nitrous acid, which diazotization reagent we can use in diazotization reaction? Do you know any reagent? Okay, have you thought? Okay, let us see which are that reagent. Okay, nitrous oxide, nitrosyl chloride and nitrogen trioxide, N2O3. So these reagents, that is nitrous oxide, nitrosyl chloride and nitrogen trioxide, so these reagents we can also use in diazotization reaction in the place of sodium nitrite hydrochloric acid, in the place of what? Sodium nitrite hydrochloric acid. But which reagent we have to use? Okay, that will depend upon which aromatic amine we are using for diazotization. That means on which aromatic amine we have to carry out diazotization reaction, that will decide which reagent we have to use for diazotization reaction. Okay, so these are what? Some difficulties, isn't it? Because of these difficulties we have to thought about different type of diazotization reaction. Okay, because of these three type of difficulties, okay, we have to thought about what? Different type of diazotization reaction. Let us see which are that different type of diazotization reaction, isn't it? You can note down it. Okay, I think you have noted down it. Let us see which are the different types of diazotization reaction. See, first different type of diazotization is direct method or direct diazotization. Direct diazotization. Okay, direct diazotization. See, in this method, a aromatic amine, okay, and 3 moles of hydrochloric acid. In this method, a solution of aromatic amine and 3 moles of hydrochloric acid are mixed with required quantity of sodium nitrite. What I am saying, in this method, which is this method, direct diazotization. Okay, what I am saying, in this method, a aromatic amine and 3 moles of hydrochloric acid are mixed with what? Sodium nitrite, required quantity of sodium nitrite at 273 degree Kelvin. At 273 degree Kelvin to give a diazonium salt. Okay, let us see one example. So, in this method, aromatic amine like aniline is reacted with 2 moles of hydrochloric acid. I am writing here 2 moles. Here I have written what? 3 moles of hydrochloric acid. Okay, 2 moles of hydrochloric acid and sodium nitrite solution. Isn't it? What will happen? At 0 degrees Celsius, there will be a formation of benzene diazonium chloride. There will be a formation of benzene diazonium chloride and byproduct will be NaCl plus 2 moles of water molecule. So, this is what? Direct diazotization. So, in direct diazotization, we have to take a solution of cold solution of aromatic amine and 3 moles of hydrochloric acid. Okay, and in that solution we have to add cold solution of sodium nitrite, isn't it? At 273 degree Kelvin to get a diazonium salt. So this is what a example. In this example we have taken aniline, and aniline is reacted with what? Hydrochloric acid, sodium nitrite at 0 degree Celsius to get benzene diazonium chloride, Okay, now see, in this method, a excess of nitrous acid is removed by, okay, excess of nitrous acid. What is the formula for nitrous acid? OH and double bond O. It is removed by adding urea. Okay, excess of nitrous acid, it is removed by adding urea. So what you will get? What you will get? You will get what? There will be a decomposition of this molecule, okay, by in the presence of urea. So urea will react with this nitrous acid. There will be a liberation of carbon dioxide gas, isn't it? There will be a formation of N2 gas, nitrogen gas. So see, there are how many nitrogen? 1, 2, 3, 4. That means we are using 2 moles of nitrous acid. Hence there are 2, 4 nitrogen. Isn't it? 1, 2 and these 2, 4. So 2 N2, that is 4. CO2. Okay. CO and this is 2. Now how many hydrogens are remain? 2, 2, 4. This one 5 and this one 6. So 6 hydrogen and 3 oxygen. So there is formation of water molecule. Okay, suppose in this method there is excess of nitrous acid. In this direct method, excess of nitrous acid is destroyed. This excess of nitrous acid is destroyed or it is degraded by adding what? Urea. Okay, now what will happen if we have not used 3 moles of hydrochloric acid? What will happen if we have not used 3 moles of hydrochloric acid? Okay, let us see. Isn't it? If we have not used 3 moles of hydrochloric acid in this diazotization reaction, what we will get? We will get benzene diazonium chloride, like what we got here, benzene diazonium chloride. Isn't it? By the reaction of aniline with 2 moles of hydrochloric acid. This is what we got, benzene diazonium chloride. Okay, now if we have not used 3rd mole of hydrochloric acid, then what will happen? Unreacted aniline molecule will react with this benzene diazonium chloride. Will react with what? This benzene diazonium chloride, and there will be a formation of a byproduct. Let us see which is the byproduct will form. This byproduct will form and there will be a liberation of HCl. Okay, this side product, this side product will form. Isn't it? What is it? Diazo amino compound. Diazos. Okay, diazo amino compound. This is what side product will form. Now when it will form? If we have not used 3rd mole of hydrochloric acid. So what 3rd mole of hydrochloric acid will do? See here, I have written 2 moles of hydrochloric acid, but in the statement of direct diazotization reaction, what I have stated, we have to use what? 3 moles of hydrochloric acid. So that 3rd mole of hydrochloric acid, what it will do? It will react with unreacted what? Aniline molecule. It will react with what? This unreacted aniline molecule. Isn't it? It will react with what? This unreacted aniline molecule, and there will be a formation of anilinium chloride. Okay, this type of salt it will form. So this salt will not react with what? This benzene diazonium chloride. Isn't it? So this salt will not react with this benzene diazonium chloride. Okay, so when this salt is not going to react with this benzene diazonium chloride, so there will be no way to form this product. There is no way to form this product, that byproduct, diazoamino compound. Isn't it? So have you understood what is direct diazotization? Okay, now you can note down it. Okay, now let us see next method. Reverse diazotization. Second is what? Reverse diazotization. Second type of diazotization is reverse diazotization. Let us see what is it. Okay, I think you have noted down it. Okay, let us see what is meant by reverse diazotization. Okay, see what is reverse diazotization. In an diazotization reaction, okay, when in an diazotization reaction, when that aromatic amine, when a aromatic amine contains a acidic group, okay, aromatic amines contains acidic group on its structure. Okay, for example, okay, when a aromatic amines contains acidic group on its structure, okay, either sulfonic acid or a carboxylic acid, then such type of compound can exist. Then such type of compound can exist in its deuter ionic form. Isn't it? So this is what a deuter ion. Similarly, you can write a deuter ionic form for this compound. SO3 minus. Okay, so when the amine, that means aromatic amine, contains a acidic group on its structure, then there will be a what? Deuter ion formation of that aromatic amine. Okay, now this deuter ion, it is what? Less soluble. These deuter ions are what? Less soluble in aqueous acidic medium. These deuter ions are less soluble in what? Aqueous acidic medium. So for such type of, that means for diazotization of such type of compound, for diazotization of what? Such type of compound, this reverse diazotization method is used. Okay, for diazotization of what? Such type of compound, reverse diazotization is used. So what is this reverse diazotization? Okay, see, in reverse diazotization, what is done? A solution of, a cold solution of, okay, cold solution of aromatic amine, okay, cold solution of aromatic amine and nitrite. Cold solution of what? Aromatic amine and nitrite are dissolved cold solution of aromatic amine and nitrite is dissolved in what? Acid. Okay, is dissolved in what? Acid, HCl, to get what? Corresponding diazotized product. To get what? Corresponding diazotized product. So this is what? A reverse diazotization reaction. Okay, so cold solution of aromatic amine and nitrite are run. Okay, what we can say? They are run cold solution of what? Aromatic amine and nitrite are run in, okay, or I can say here, run in hydrochloric acid solution or hydrochloric acid medium. Okay, so this diazotization reaction will take place. Then there will be what? Diazotization reaction will take place. Okay, that means we have to take aromatic amine and nitrite solution all together at 0 degree Celsius, and that solution we have to run in what? Hydrochloric acid solution. Isn't it? Then this then this reverse diazotization reaction will take place. Okay, now let us see third method and last method for this diazotization, which is called spatial diazotization. Okay, what it's called? Spatial method of diazotization. Spatial diazotization, or you can say spatial method of diazotization. So what is this spatial diazotization? See, in this reaction, spatial diazotization, compounds like what? A aromatic amine, isn't it? And that aromatic amine is having easily oxidizable functionality. Compounds like what? A aromatic amine, and that aromatic amine is having easily oxidizable functionality. Okay, so this hydroxyl group can undergo oxidation. This hydroxyl group what? Can undergo oxidation during what? Normal diazotization reaction. Okay, during what? Normal diazotization reaction. Hence, we cannot carry out direct diazotization or a normal diazotization reaction with such type of compound. Isn't it? Hence, what we have to do? We have to react such type of compound with copper sulfate. That means we have to react this type of compound with what? Sodium nitrite. With what? Sodium nitrite in presence of copper sulfate. In presence of what? Copper sulfate at 293 degree Kelvin. At what? 293 degree Kelvin. So what we will get? We will get a diazo oxide. What we will get? We will get a diazo oxide. We will get this diazo oxide, isn't it? So what is spatial diazotization? Spatial diazotization reaction is generally used for a compound which are having what? That means this spatial diazotization reaction is used for those aromatic amines those are having easily oxidizable functionality like hydroxyl group, isn't it? So we can react such type of compound with what? Sodium nitrite in presence of what? Copper sulfate, CuSO4 copper sulfate at 293 degree Kelvin. So there will be a formation of what? Diazo oxide, isn't it? So this diazotization took place here. So this is what? Spatial diazotization reaction. Okay, so what we have seen? We have seen what is meant by diazotization. Okay, how diazotization is carried out. Okay, what are the reagents for diazotization? Okay, what are the difficulties are observed in what? Diazotization reaction. Next point, what we have discussed? Then we have discussed different method for diazotization reaction. Different method for diazotization reaction. First we have seen direct diazotization. Second we have seen reverse diazotization, and third we have seen spatial diazotization reaction. So this is what about diazotization reaction. Okay, diazotization unit process we can say. I hope you have understood this topic. Okay, thank you very much. Wish you happy learning. Thank you.